Morning to all. Myself, Dr. S. Mohamed, Assistant Professor of Mathematics. My topic is graph theory and its applications. What is graph theory? Graph theory, introduced by Euler, papers on 7 Bridge of Königsberg, published in 1736. It's one of the famous problem on traveling salesman problem. A traveling salesman problem is to visit a number of cities. How to plan to trip to every city is visited once and just once, and the whole trip is short as possible. It is also a famous problem. 1852, Francis, one of the derived the fourth color problem, and in 1976, Apple and Hagen is a birth of graph theories. Also a famous problem of graph theories. Use of graph theory is cause of writing electronic components shortest route between two cities and the shortest distance between all pairs of cities in a route at last. Matching resource allocations, task scheduling, visibility, and coverage. Um, it is also for the graph theory examples. What is graph theory? Graph theory is informally a graph is a set of nodes joined by a set of lines or arrows. Uh, Graph is a pair of vertices and edges. E is called vertices, E is called edges. G is an order of triple. G is equal to E, comma E, comma F. E is a vertices, E is a edges, F is a functions. V is called a set of nodes or points or vertices. E is a set of whose elements are known as edge or lines. Efficient functions. Each elements of E to 100 pair of vertices in V. These are definitions of vertex. Basic element drawn as a node or a dot. Vertex set of G is usually denoted by V of G or V. Edge. A set of two elements drawn as a line connecting two vertices is called end vertices or end points. The edges set of G is usually denoted by E of G. Did you see examples? 1, 2, 3, 4, 5, 6 are vertexes. It's called a vertex. Edges is a pair of vertices. 1, 2, 1, comma 2 is a edge. 1, comma 5, and 2, comma 3, 2, comma 5, 3, comma 4, 4, comma 5, and 4, comma 6. A simple graph. What is simple graph? Simple graphs are group graphs without multiple edges or self loops. And path. What is path? A path is sequence of vertices such that there is an edge from each vertex to it is successive. A path simple if each vertex is distinct. This is a cycle. What is a cycle? A path from a vertex to itself is called a cycle. A graph is called cyclic if it is contain a cycle. Connectivity is connected if you cannot get from any node to any other by following a sequence of edge or any two nodes are connected by a path. A directed graph is strong connected if there is a directed path from any nodes to any other node. It's the spare tense. Spare called a graph is sparing modulo E equivalent to modulo V. Tense is called modulo E equivalent to modulo V whole square. A weighted graph. What is weighted graph? It's a graph for which each edge has an associated weight, usually given by a weight function, W function of E to R. It's examples of weighted graph. Directed graph, which have directions. An edge ordered pair of nodes. It is called a directed graph. And the another one is bipartite graph. We can partition into two sets sets V1 and V2 such that U comma V also belongs to E, which implies either U belongs to V1 and V belongs to V2 or V belongs to V1 and U belongs to V2. Special types. There are many special types in the graph. The one of empty graph or edgeless graph. It is called no edges. That is called empty graph. Null graph. Null graph means no needs, no nodes. Obviously, no edges. That is called null graph. Another one is completed graph. The completed graph denoted by Kn. Every pair of vertices are adjacent. Has n into n minus 1 edges, that is called it is a complete graph. Complete bipartite graph. Bipartite graph variation of complete graph. Every node of set is connected to every other node on the other set. Planar graph. What is planar graph? Can be drawn on a plane such that no two edges intersect. That is called planar graph. K4 is the largest complete graph that is planar. Dual graph. Faces are considered as in nodes. Edges denote face adjacency. Dual of dual is the original graph, that is dual graph. And another one's important topic is tree. Connected cyclic graph, that is called a tree. Two nodes have exactly one path between them. Any other two vertex have exactly one path between them, that is called a tree. Generalization of hypergraph. What is generalization of graph? Edges cannot connect any number of vertices formally, and the hypergraph of a pair, that is x comma e, where x is a set of elements is called nodes or vertices, and e is a set of subset of x. It's called hyper edges. Hyper edges are arbitrary sets of nodes. They contain an arbitrary number of nodes. Degree. What is degree? Number of edges incident on a node. That is called degree. The examples of graph is so degree is 2. Directed graph. Degree of directed graph. In degree, number of edges entering. Out degree is number of edges leaving. That is equal to in degree plus out degree. That is called equal to degree. Degrees of simple facts. If G is a diagram with m edges, then summation of integers in degrees of V, that is equal to summation of out degree of V, that is equal to m, that is also equal to modulus C. If G is a graph with m edges, then summation of degree of V, that is equal to 2m, that is called equal to 2 modulus E, that is equal to number of odd degree and node is are even. Subgraphs. What is subgraphs? Vertex and edge sets are subsets of those of G. A subgraph of a graph G is a path. Contain H is some graph of G is H or isomorphic to H. H is a proper subgraph if H is equal to G. Spanning subgraphs. Subgraph H has the same vertex set as G. Possibility not all the edges. H span G. It is the examples. Infused graph. For any pair of vertices x and y of H, xy is on edge of H if and only if xy is on edge of G. H has the most edge of that appear in G over the same vertex set. If H is chosen based on a vertex subset S of V of G, then H can be written as G of S. A graph that does not contain H as infused subgraph is said to be H-free. Component. What is component? Component is a maximum connected subgraph. It is called component. Isomorphism. Isomorphism means bijection. So one to one and onto. One-to-one mapping of function of V of G map to V of H. U and V from a G are adjacent if and only if F of U and F of V are adjacent in H. If an isomorphism can be constructed between two graphs, then we say those graphs are isomorphic. Isomorphism problems. They say isomorphism, determining whether two graphs are isomorphic. Although these graphs look very different, they are isomorphic. An isomorphism between them is f of a is equal to 1, f of b is equal to 6, f of c is equal to 8, f of d equal to 3, f of g equal to 5, f of h is equal to 2, and also f of I equal to 4, f of j is equal to 7. The graph abstract data type. What is graph abstract data type? A computer science graph is an abstract data type that is called ADT, that consists of a set of nodes and a set of edges. Establish relationship connectiveness between the graph. A graph ADT follows directly from the graph concept from the mathematics. Representation of matrix. Incidence matrix edges cross vertex. This contains of edges data. Adjacent matrix, it's called B cross B, Boolean values. Adjacents are not are adjacent weight. Representations of edge list. Pairs of vertices, optionally weighted and other data, adjacency list. The adjacent as a implementation of a graph, adjacency will be a list of representations on array of modulus B list. One for each vertex in V, for each U belongs to V. Adjacent U of points to all its adjacent vertices.